So you can use yesterday's notes to definitely help you in support of today's question.
I can't see the question.
Yesterday we talked about one of the mathematical mindsets, which is our background knowledge. What do we know? What do we know about this problem? Let's do, make sure we're going to start off today with an independent, productive struggle. So that mathematical mindset of what you know. What do we know? What are some of the bigger ideas that we need to know about this problem in order to start it?
We have 36 marbles total.
Okay, we have 36 marbles total. What else is a big idea here? Yeah?
There may be a lot more yellow marbles because people have pulled out 16.
Okay, so we know, good. We know that out of the 36 marbles is going to be, most of them should be yellow. Okay? Yes?
30 total tries.
That's a big one. That we know there are 30 trials. What does that 30 trials mean, Dylan? Explain that.
That means out of the total trials out of red, yellow, and blue, like the times they've taken marbles out of the bag, it's 30 times.
So they reached in that bag 30 times. 4 of them were red, 16 were yellow, 10 were blue. So Dylan, if I know that, how can I represent the red probability now?
4 over 30.
And then I would have 16 over 30 and 10 over 30. That is my probability, my fraction. What about as a decimal, what do these equal now? Because we should have been able to get to that point. What do they, Braden, what do they equal as a decimal, these probabilities?
30 over 30.
Well, no, what does this one equal? Sorry, individually.
13%.
So 0.13?
Yeah.
What's this one?
0.53.
0.53 and 0.33. So here I've got my 3 probabilities, and this is something I like about probability, that one of the mathematical mindsets that we need to be practicing all the time is this a reasonable answer? So are these reasonable answers, and why? Yeah?
When you add them all up, it'll get pretty close.
Yeah. This is almost 1, right? We add them up and we get 99. Why doesn't it get 100?
I don't know. Can you
Rounding. We rounded down. I think you rounded down here and you rounded down there. And then we rounded down there. So all 3 were rounded down. So we lost a whole somewhere. Or we lost a 10th somewhere. So, but if I add these up, I get 0.99, which tells me, okay, that is almost 1. I probably did it correctly. It's just our rounding messed up. Now I know that 13 is 13%, 53%, and 33%. So if I'm reaching in this bucket here, okay, and I reach in 30 times, and there's marbles in here, what percent of them are red? 13%. That's what I'm assuming based on my data. What percent of the marbles are blue? 33%. Because that's based on my data, that's what it's telling me right now is that 33% of these are blue, 13% of them are red, and then over half of them are yellow. So the big question is, now that I know the percentages, talk your tables, how do I figure out how many of these 36 marbles are actually yellow, red, and blue? Go.
Okay, so what?
That's cool. You guys did a great job because I was listening to this group over here. Otis was saying, you're going to take your total number of blocks that are in there, and you're going to say, hey, what is 13% of 36? So it's 36 times 0.13, and what do you get, Otis?
You get 5.
5 reds.
19 yellow. And 12 blue.
Do these numbers, again, mathematical mindset, is it reasonable?
Yes.
Why?
Because they're all under 36 and they all equal 36.
Nice. Okay, so we know they're all under 36 because should be. And when I add them up, I get 36. I can even go further. What else can I notice that would be like, boy, that's a reasonable answer, like, for instance, yellow.
Like for yellow, 19 is almost half or 30.
Good. So 18 would be half of 36. 19, pretty darn close, should be a little bit more. It is. Great. We know that this should be a third. 12 is a third. So we've got some good reasonable answers, and they do equal 36. Questions about that? Remember that I want to just leave you with that mathematical mindset of, is it reasonable? With probability, it is so awesome because it does actually work to check. You can actually check to see if it's pretty darn close because probability equals 1. And then we know when we use them and we get numbers that those numbers should be equaling what's being asked. Today we're going to look at outcomes for an event. What's an outcome? Addie? Yeah, result. So we're going to be looking at an event, flipping coins, but the event has multiple flips. And then we're going to look at those outcomes. Before we do, your homework is this. This is for tonight. This will get you ready for the test. I have pushed the test back till Monday. It was going to be tomorrow, but I want to give you another day because I feel like I want you to be more successful. So tomorrow we're going to be doing 2 questions in 2.4 that I feel are really going to be beneficial for you, more of a workshop method. And then this also will help you tremendously to understand what kind of questions are going to be asked. And it is already on Google Classroom. So if you lose it, you can go to the classroom, check it out, just grab a piece of paper and just answer the questions. Okay, so you don't even need this per se. since it's on the classroom. Any other calendar things? Nope. Okay. We're going to go back, Eli. We're going to wait to the end to do this. Okay, so what I want you to do right now is pull out the paper you grabbed at the door. So we will go back to the homework, but not right now. 2.3. Okay, so first thing I'd like you to do, with 2.3 in front of you, read page 32, and then write the definitions of the following three terms. When you finish those definitions, I'd like you to start working on, with the independent productive struggle, on page 33. So once you guys finish your vocab, please start on page 33. A little bit of productive struggle, and then I'm going to do a teach. But remember, if you can't answer the first question, maybe you can answer the next one. So what you're going to be doing is creating some schema, some ideas about what you already know, which is really important. So what is the sample space? Look at your definition of sample space. So use a tree diagram. What is the sample space? So what's a sample space?
Another name for step past walk.
For all the outcomes. Hmm. That's the sample space. Good work. Nice job, Jayla. It looks like, though, you've only flipped it 2 times. And they're flipping the coin 3 times. All right. Go ahead, turn your paper back over. What this does, it allows me to kind of see what I need to cover with you, because I feel like the majority of this you're going to get pretty quick. So it is, what are the 2 boys' names?
Tevi and Santo.
Tevi and Santo. So they're flipping a coin 3 times. Okay, so have your paper over on the other side on 2.3. They flip it, goes over, they get a head. So on your paper, whoops, this is coin flip number 1. I want you to write this down on yours. Coin flip 2. Coin flip 3. And the last thing I'm going to write over here, outcome. And I know that this is considered my sample space. So I just got a heads. So that automatically puts me on this track on this tree diagram. I'm no longer on this track down here. I'm on this one. Flip it again. Heads again. Ooh. And then I flip it one more time. That's right. Heads again. So my outcome is H, H, H. And that's only one outcome in my sample space. That's the one I got. So on your paper with your table, I want you to list all the outcomes that we could get by flipping a coin 3 times. Okay? And you can work together. Go. So I listed all the outcomes. And what I did is I just kind of followed the tree diagram all the different ways. So here I had the heads. Here I have heads, tails. So I wrote that one down. Then I go heads to tails to heads. Heads to tails. You get the idea. That's how I create my sample space. So this is my sample space. What was the chances of getting heads? Is it like super rare, like even more rare than any of the others?
No, 1/8 to get heads.
How'd you get 1/8? Because there's 8 possible outcomes. And heads is one of them. That's the only place I can get a heads. So, but if I said to you, well, what are the chances of getting 2 tails?
Then I would say back to you, the chances are
Okay, your outcomes.
1 out of 8.
Or 2? No.
Oh, wait, no, two out of
Just 2.
2 out of 4. Maybe?
What are the chances if I flip a coin that I have 2 tails as a possibility?
3 out of 8?
No, 2.
You say 3? Well, is there 2 tails there? Nope. 2 tails there?
Nope.
Nope. Yes. So there's 1 right here. No. Yes. Yes. And yes. So 4 out of 8 chance, which it means a half, right? So I would have a 50% chance, theoretically, not experimentally, but theoretically, if I flip this coin 3 times, 50% chance of getting 2 tails. What do you notice? I got a tail.
What?
And another tail. Boom. So that actually was like, well, it's a 50% chance, right? 50-50 to get at least 2 tails out of all my outcomes. Now that's not experimentally, that's just theoretically. And that's all based on, this is my desired outcome, and this is how many outcomes I have. So I could get my outcome as 1/8 that way, but I also can do it another way. And this is kind of leading into more tomorrow. But what are the chances here of getting a heads? 50%. 1/2. What are the chances of here? 50%. And what are the chances here? 50%. If I take, and this is a big idea in this unit, when I have multiple events leading to an outcome, I can take the probability of each event, multiply it, and find the probability at the end of getting it. So I have 50% chance here, 50% chance. What's 1/2 times 1/2? 1/2 times 1/2. A quarter. It's 1/4. Right? Because what's 1 times 1? 1. 2. 1 times 1 is 1. 2 times 2 is? So up to this point, I have a quarter chance. And if you look, how many outcomes do I have? 1, 2, 3, 4, with the tails or heads in front. And then I take that quarter chance, I multiply it by another half, and that's where I get my 1/8. because 1/4 times 1/2 equals 1/8. So I have a probability of 0.125, or that equals 12.5% of getting any of these outcomes. And the way I figured that out is I take each probability and I multiply it to find the total probability of getting just one of them. Or you can count the probability. You can count the outcomes and then put the 1 over how many total outcomes, and you can figure it out that way. But this is 1/8. They're the same. So I've given you enough. You should be able to go ahead. Definitely. Now, a lot of you are going to want to go back to A and tackle A1 because it's not quite correct how you answered the sample space. You're going to do A1 through A5 independently. Then you can write your name in the MPS. While you're waiting for a partner, you can work on your review sheet. Once you get a partner, go to B. And make sure you check your work. Answers are up there.
So for A1, do I have it right?
So it says use the tree diagram from above. We're talking about this one.
Okay.
So, and it says, what is the sample space of tossing 3 coins? Coin 1, coin 2, coin 3. So what's the sample space? What do we talk about the sample space? The sample space is what?
This.
All of your outcomes. That's your sample space.
Okay.
So you would want to write down, which you already have it on that side, but you would want to write down all of the possibilities, which are right here, all the different outcomes.
Okay, so would I be able to write these ones down then?
Yeah, there, because look, I flip, I get a heads, I flip again, I get a heads, I flip again, I get a heads, right? That's what I got. Okay. But I could get a heads, heads, and tails. I could get a head, tails, tails. You understand now? Mm-hmm. So this is my sample space.
Would the sample space be like 50% because there's a 50% chance of that or not?
Okay. Read sample space.
Instead of all possible outcomes in a probability.
Okay. It's all possible outcomes.
Okay, so heads and tails would only be 2. There's only 2 possible outcomes.
If I flip a coin 3 times, there's only 2 possible outcomes?
No, there's 6 possible outcomes. Heads, tails, heads, tails, heads, tails. Did I do something wrong?
Well, no. I want you to think about it. If I flip a coin 3 times,
Right.
what are all the possible outcomes? We just wrote them down.
Oh, okay. There's... Oh,
And you need to write them down.
Where? Just how many numbers there are? I have
No. It's asking you, what is the sample space? Meaning you need to tell me what they are.
like all of them.
What are the outcomes? Yep. Because that sample space is your outcome. All the different outcomes. So you don't have all the outcomes yet. You have 1, 2, 3, 4. You only have 4. Okay. All right. It's on 33. Wait a minute. Are you A4? What is the theoretical probability that exactly 2 of the coins are going to match? Exactly 2 coins. Not 3 coins, just 2 coins.
Oh, okay.
So what is it?
Not that number?
Well, what are you thinking?
Does it include the ones where all 3 match?
No, because that wouldn't be exactly 2.
Oh. All right.
Right? It's that word exactly that matters.
I'm just gonna do that.
So how many would it be?
25%.
Show me them.
That one. And that one.
What about this one? Do 2 coins match there?
Oh, I understand it. Okay. Thought it just meant like 2 tails.
No, it doesn't say 2 tails. It just says when 2 coins match.
All right. %50 chance then.
You're pretty close, because I'm seeing that's what he got too. Do they match if they're not in order?
Yeah.
You tell me.
Yeah, because there's
Like if I have an apple, a pear, and an apple. Do I have 2 matches? Okay, so they don't have to be in order either.
Oh,
Aha.
okay.
Does that make sense?
Yes.
Make sure you guys are checking your work. Yeah. What about it? There's a reason why I have partner work.
just like did this weird rant thing. I didn't really catch any of it. I did that.
Well, suppose you toss the coins for 24 trials. You don't have to, because it says suppose. It doesn't say conduct. So how many times would you expect coins to match? Well, what's a match mean? I'm still tossing it 3 times. I'm still doing the same experiment. Okay. Do they have to be side by side? Okay. Right? Because if I have an apple, pear, and apple, I still have a match, even though they're not necessarily right beside each other. If I have an apple, apple, and apple, well, that's 3. That's not 2.
But it does have 2 in it, so it's still technically
Okay. So I do this for 24 trials. What do we know about more trials? Okay. What are you doing?
I've gotten 2,700
Oh my goodness. Okay. So they're just like, okay, so up in A4, it said, what is the theoretical probability that exactly 2 coins will match? I'm assuming, suppose you toss 3 coins for 24 trials. How many times would you expect 2 coins to match? That's it. I mean, you have 3 coins, you toss them. They land. How many times do you expect 2 coins to match?
No, 75%. No, 50%.
Okay, I want you 2 to talk about it. Okay, think about because I'm asking you to solve it 2 ways. So you can show me mathematically. Okay, you can also show me with a sample trial. Okay, there's a reason why I have that up there. It's a simple but yet difficult question. Yeah.
So we got the at 12, but we don't get until 8.
Because, okay, so you're only expecting it 50% of the time. Why? Like, what did you guys write? And you didn't use the mathematical rubric. It says use the rubric.
Would you expect the 2 coins to match?
I said yes, or I said I would expect the 2 coins to match 12 times.
Why only 12?
Because if there's a total of 24 trials and then there was 8 trials, that's just multiplied by 3. So I thought.
Okay, using a scale factor. Okay, so I got you now. So if I have and I've been using this as my example, an apple, a pear, and then an apple. Do I have a match? So I have a match even if they're not apple, apple, pear. So why don't you go look at your outcomes and count again how many matches you have in your outcomes. So we'll go look at your sample space, figure out how many matches you have. Not triples, matches. Triples are different, right?
Do you have 2 coins or what?
Well, you tell me. Is it fair? Is the game fair? Like, is it like, are you more likely to get one answer over another? Why?
Well, if he only has 1 coin, he has 2. He's more likely to get it.
No, they're flipping all 3. He just doesn't have 3 hands, right? Yes.
So, B, what would you have to do? You got an 8, but I don't know if that's B, U.
I don't know if that'd be right though.
Hey, let's come back together up here. So I want to talk to you guys about B. On B, it asks for a match. Still flipping 3 coins. 1 coin, 2 coins, 3 coins. What would be a sample of a match? Yes. Okay. Heads, heads, tails. What would be another sample? Yes. Tails, heads, tails. What would be another one? Yeah. Tails, tails, heads. Say it again. Heads, tails, tails. Heads, tails, heads. I'll just tails, heads, heads. How many?
6.
6. Now, let's say I do, so how many possible outcomes are there?
8.
8. So what's my probability? 6 out of 8, which is what? Hey, Tatiana, you're going to have to stand up because you're talking while I'm talking, please. Or Eliza, either one of you, doesn't matter. All right, 75%. So that means 75% of the time, I should be expected to get a match, right? Okay, a triple isn't a match.
Yes, but it,
Well, they're not, I'm telling you that they're not considering it.
Just 2 matches in 1 trial.
it said
That's
that
what he's asking.
exactly 2 points will match. It didn't say but exactly 2 points
Matching.
are matching.
All right, so here's my question. If I do 30 trials, what should I expect?
About 75% chance.
If I do 100 trials, what should I expect? Okay. My probability, my theoretical probability is not going to change based on more trials. It's going to stay the same. Because theoretical probability says this is your chances. More, if I do the experiment, I'm probably not going to get 75% if I only do it 8 times. But if I do it 30 times, 40 times, I'm probably going to get this. So that brings me to the next question. I want you to put that away, and I want you to open up to page 36 and go to 3. Question 3. Yeah, it was your homework. This has been a really good question. And I wasn't, when I assigned it, I wasn't actually expecting it to be, but then after reading, I was like, oh, yeah, that is hard. Or it's kind of difficult to comprehend. So you got these two kids on page 36, Cam, or 37, I believe, sorry. Number 3, Bailey uses the results from an experiment to calculate the probability of each color being chosen from a bucket. He's doing what I did yesterday. He says, now he's just using the results. These were his results. Red was 35% of the time. Blue was 45% of the time. I don't have a yellow. And we'll do black. And yellow is 20%. He did the experiment. Jared uses theoretical probability, and he says, hey, theoretically, red is supposed to have the most, 45. Blue is supposed to have the second most, and then yellow is supposed to be the least, theoretically. On Bailey's turn, okay, the kid who did it first, he predicts blue. Why would he predict blue? Yeah. He did the experiment. He got blue as the most. But Jared says theoretically, red should be the most. Why is Bailey's information different than Jared's? Callie.
Because they're doing an experiment.
And what do we not know about the experiment?
We don't know, like,
How many trials? He could have only done it 8 times. Does that make sense? So if he's done it only like 5 times, he's like, man, look, red, I'm going with blue, baby. But theoretically, you should go with what theoretically should happen. That would be, if you're a gambling person, you don't go with the worst probability. You try to stay with like the higher probability, right? But it's not to say that will happen. So did the boys make a reasonable prediction? Well, Jared does, because he's saying theoretically, over time, red will happen the most. We know that theoretical probability will match, experimental will match theoretical over time. That's why Las Vegas stays in business. Because when you go to Las Vegas and you play cards, or you do the roulette table, or you're playing any dice game, the odds are against you. That's how they make money. Right?
They make it seem like you can win.
Right? You go to the slot machine, you do that. The odds are against you. But you have the possibility to be Bailey. Put your coin in, crank it, and boom, you get cherries across the board, right? Boom, yeah, winner. But ideally, if you keep playing, what's going to happen? You're going to lose, period. That's just how it works. That's how Vegas makes money. You make money, and then you keep playing, and then you leave broke. So, anyway, probability. Go ahead. Let's get our exit tickets out. All right. We have 3 questions. They're super easy. I just want to make sure we're on the same page with this. Yeah, that was a good one, because a lot of kids said, well, yeah, of course Bailey made a good decision. No, he didn't. He should have chose the one that theoretically is going to get pulled the most. But Chill, what'd you do to it? Thank you. I don't know. It's tired. Okay, can probability ever be 0? Can you have a probability of 0? Yes. Yeah, pull a green out of our bucket that only has red and yellow. That's 0 probability. And that could be how I explain. You cannot pull a green out of a bucket with just red cubes. Can a probability ever be 1? Matthias, can you have a probability of 1?
Yeah.
Give me an example.
You have like 100 cubes and only one of them is white.
Ooh, make it 100 cubes, all of them are red. What are the chances of me pulling a red cube out? 100%, 1. Good, that's it, right? Like, if I have a bucket full of red cubes, it is a probability of 1 that I am going to pull out a red cube. What about a probability greater than 1?
Nope.
Nope, can't happen. You can't have something that's like more than certain, like extra special certain.
Like 100.
Okay? You know, when I was thinking about this, but when you have coaches say, wow, man, you gave 110% out there. What they're actually saying is that, wow, what you were expected, what you could achieve before is now higher than what it used to be. Like you achieved more than what you used to be able to achieve, but you can't really achieve more than 100%. What you did was you raised your ability to achieve more. I geeked out on this last night. You can tell. I was just sitting there thinking, I was like, where does that come? Well, it's like, no, you can't, because you can't do more, but you raised your ability to do more, which is still 100%. So I'm going to correct all coaching and all coaches in the entire world and tell them, no, that's not going to work.
Practice